In this video we are going to look at more examples on integration using substitution, or also known as integrals of the form the integral of f of u du by dx with respect to x. So let's look at the first example. Find the integral of 6x divided by the square root of 3x squared plus 7 with respect to x. Now this integral can be rewritten as the integral of 6x times 3x squared plus 7 to the power of negative half, and it's negative a half because it's a square root from the denominator with respect to x. Now let's consider a substitution. So I'm going to let u be the expression in the bracket here. So that's 3x squared plus 7, and therefore du by dx will be the derivative of this expression. The derivative of 3x squared is 6x, and the derivative of 7 is 0. If we start putting this back into the integral, so the integral would be, now this here would be u to the power of negative half, and then we have 6x that can be replaced by du by dx, and with respect to x. So this is the integral of u to the power of negative half. Du by dx with respect to x ends up being du, and therefore the integration here would be integrating u to the power of negative half is u to the power of negative half add 1, so that would be half, divided by the new power, which is a half, and then plus constants. Now the final step is we put back the value of u, so that would be 3x squared plus 7 to the power of a half, and of course you can write that as a square root, over a half, which is over 1 over 2, so that 2 can be multiplied here, and then plus constant. So this could be the form, or you can also write it as 2 the square root of 3x squared plus 7, and then plus a constant c. Let's look at another example. Find the integral of 2x cubed times e to the power of x to the power of 4 plus 2. We're still going to use substitution, so I'm going to consider the substitution in which we will let u equals the power of e, which is x to the power of 4 plus 2. If u equals x to the power of 4 plus 2, then du by dx is the derivative of this, which is 4x to the power of 3. Now before we start putting this back into the question, if we look at this here, this is 4x cubed, while this one here is 2x cubed. So to make it easier to replace, I'm going to divide this by 2, so I get half du by dx is equal to 2x cubed. Let's substitute this back here. So again, just to clarify this, what I did here is that I took this expression to be the same as this expression here, which is u, and took this expression here to be the same as this expression here, the 2x cubed. So this would be now the integral of e to the power of u, and then the 2x cubed, which is this here, can be replaced by half du by dx, and don't forget that dx in the question. Just rewriting this here, half is a constant, so that can be written outside the integral sign, so half of the integration of e to the power of u, and du by dx with respect to x will end up being du, and then therefore the integration is half, and the integral of e to the power of u is e to the power of u plus constant. And then the last step, replacing u and putting it back to its original value. So e is to the power of x to the power of 4 plus 2, and then plus constant. So the final value is half e to the power of x to the power of 4 plus 2 plus constant. Let's look at another question, or another example. Find the integral of x squared plus 2 over x cubed plus 6x with respect to x. Now, in this question here, we are going to use this rule for integration. So the integral of f dash of x over f of x with respect to x is equal to ln modulus f of x plus constant. So we'll keep this here because we will use it later. So again, we are going to consider a substitution, but before this, actually we'll do so. Let u be the denominator, which is the bigger expression here, or the expression of the higher order, so x cubed plus 6x, and therefore du by dx equals the derivative of this, that's 3x squared plus 6. Again, if we look at these expressions, this looks like the denominator, but this one here does not exactly look like the numerator. So I need to make some changes. If I take a common factor of 3, that will give me 3x squared plus 2. And now this looks like the numerator. So to get rid of this 3, we divide by 3, so that would be 1/3 of du by dx is equal to x squared plus 2. So what happens here is that this is this expression here, and this is this expression here. If we start replacing this, so the integral now would be the integral of, now the numerator is 1/3 of du by dx over the denominator is u, and then dx. But let's rewrite this. Now 1/3 is a constant, so that it can be written outside the integral sign. And then du by dx with respect to x will end up being du over u. And now that brings us back to this here, the derivative of a function divided by the function. So the integral is ln modulus the function. So that will be 1/3 of ln modulus u plus constant. And then the last step would be 1/3 of ln modulus u originally was x cubed plus 6x plus constant. So the final form is 1/3 of ln modulus x cubed plus 6x plus c.